lagi ni, Naim. Plus dot saya kata berapa? Ada berapa?
3.
So yang ini saya pangkah je ya. Because there's no such thing as dot 4. Yang ini. Kemudian the first infinite polynomial, the second one ni dengan the third one ni buat apa? Dia buat apa ni? This is the first series solution, the first expansion of the first series. B4 ni, apa kena B4 dengan yang atas ni? Okay, the plus sign is not there. Right, saya tak ada bagi markah ni. Plus, kalau untuk, plus pula. Sorry, because the second term ditolak, so should be tolak B4, tolak it should be here. And then again plus sebelum C1. Nampak tak Naim? Salah you. Ada 2 kesilapan dekat sini. Plus dot u melebihi 3. Simbol negatif dan positif untuk subtraction dan addition you tak ada. Okay, so this is wrong also. And then last final answer sama dengan pun tak ada. So A0, A2, yang ni betul, A3 betul. Dan lastly, walaupun nampak betul dalam final exam, saya hanya bagi you kosong sahaja. Nampak tak ni? Nampak macam betul. Naim, are you okay? Jangan buat macam ni nampak? Penat buat panjang-panjang, saya bagi hanya kosong markah sahaja. Sebab ianya tidak memberi apa-apa makna sekiranya you buat begini. Seolah-olah you buat 2/4 tambah 1/4 3/4 4/4 kemudian dapat 4/4. Ada makna ke begini? Apa sebenarnya yang saya nak? Kalau saya yang ini, masa you all buat fraction dulu, cikgu kena bagi markah berapa? Yang ni semua saya akan bagi markah. Sebab tidak ada makna untuk Aggie. Nampak tak? Apa silapnya saya di sini? Saya kena letak apa? Saya kena tolak betul. Dan final answer saya adalah, nampak? So please with and without the annotation, saya bagi pangkal sahaja. Sebab makna berbeza, tidak ada kaitannya antara first line with the second line. Is it okay, Naim? I hope the rest pun buat yang benda yang sama juga. Saya tak nak bahasa SMS dalam matematik ada bahasa dan you have to write properly. Okay, this is good. When you betulkan alright. Ada apa-apa soalan lain? Can we start? Is it okay? Can we start? 9:21 already. So we have covered step 9, which is the final answer. We only covered step 5, which is addition and subtraction of the series. Now we are going to do differentiation of our series. This is will be step 2 in the process of series solution. Step 2, you need to differentiate. Okay, there are two types of power series. One is power of n, another one is power of n plus r. And this r should be any real numbers. N is just a positive integer. Positive integer maksudnya apa? What is positive integer? Anyone? Are you still there or taking a break? Am I talking to myself again?
Nombor dia sentiasa positif.
Yeah, I know it's positive. What will be integer means? Can I have 1.5?
Integer tu means a single number.
Nombor nombor
Nombor bulat.
bulat. 1, 2, 3, 4, 5 and it goes on, right? But the R value here is any real numbers. It means the value of R can be anything. R boleh jadi -1, R boleh jadi 0.5, R boleh jadi square root of 2, R boleh jadi negative pi and it goes on. Tak ada masalah R can be any real numbers. So N is just nombor bulat, 1 tambah R, 1 tolak pi, 1 tambah 0.5, 1 tolak square root of 2 dan seterusnya. So there are two types of power series. We are looking at how to differentiate the power series. Okay, let's consider power series on the first one. So this is the power series, power of n. So in order to differentiate, this is the notation that we are going to use, dy dx y, because we are using y as the independent, y as the dependent variable, and then x your independent variable. Okay, expand the series as its finite polynomial. So we have this. Okay, the first term when n equals to 0 is a0, when n equals to 1 is a1, plus n equals to 2, a2, and n, it goes on up until infinity. So this is what we expand. When we have infinite polynomial, it will be much easier to differentiate. Sama macam polynomial biasa, apa dia punya rule of differentiating polynomial? If I have y equals to ax to power of n, rule of to differentiate polynomial macam mana? Y prime of ax to power of n, what would the answer?
Nax n minus 1.
So a n x to power n minus 1. So I mean the power series, you bring it to the front times the constant, coefficient of the polynomial, and then the index of the polynomial, tolak sah. Similar to the one that we have here, since this is already in an infinite polynomial, the way we differentiate is sum, biji sum. When we differentiate constant, we'll get 0. When we differentiate a linear, we get just the constant. When we differentiate the quadratic x kuasa 2, then we have 2a 2x. Now 2 minus 1 is just 1. And it goes on. Again, when this is in the form of infinite polynomial. When we change it to polynomial, when the n now start from 1, so n is start from 1, and then n, a n, x n minus x naught n minus 1. Sama nampak? You just bring this to the front, and then the power n minus 1. So it means when we have this, bawa ni ke depan, that's why I have n a n, and then my n will be n tolak 1. And my n start from 1. Kenapa? Because we no longer have the A0. Dia ada A1 je. Bila n 1 jadi 1, A1 kuasa kosong. That's why we get, this is the first time. Kalau you expand this, when n equals to 2 dapat 2, A2, 2 tolak 1, 1. So this is the second term, n equals 1. Kalau kita differentiate for second time, sekali lagi, again, bila differentiate A1 dia dapat 0. Bila differentiate the second term 2A2, x minus x0, you get 2A2 because this one is just linear, right? And then it goes on. Are you okay with this? So again, when we have an infinite polynomial, change it to series, we get n, okay, bring this to the front, n minus 1, an, and this one we minus another one, that's why we get n minus 2. Again, the starting point will only start at 2. Why? Because A1 kita buang, right? So what will be the answer for, did I give the answer? Yeah. For what will be the answer for y? The third time, sama. How about the fourth time? What will be the answer? Kita buat sama-sama. Okay. It should be what? Bring this to the front, right? So n, boleh tak sama-sama dengan saya? N lepas tu apa?
N minus
1. N minus 3 kan? Kemudian an x minus x0 power of,
-4.
alright. And my n start from
4.
So each time you differentiate, okay, when you differentiate for the first time, A0 hilang. That's why they start dari 1, nampak? When you differentiate the second time, A1 you hilang. That's why they start daripada 2. When you differentiate the third time, A2 pula nanti hilang. That's why you start at 3. When you differentiate at the fourth time, that's why A3 nanti akan hilang. So n equals to 4 akan you start at. Are you okay with that? Okay. So now let's consider power series yang the second one. Is it okay? Are you all understand this? Any questions so far? Okay. So we look at the second term. Ayom sedih saya tak nampak. Let's consider power series B. Okay, again we expand the series as infinite polynomial, and then this is what we get. Ada yang tak faham tak? How do you get that? Oh, apa pula? Okay, when we substitute the values of n equal to 0, I get A0, x minus x0, n yang kosong, but you still have r. So that's why power r, power 1 plus r, power 2 plus r. Are you okay? Then when we differentiate sama when we differentiate the first time, r ni you bring to the front, dapat ni, and r minus 1. While the second term pun sama, this one bring to the front, dapat ni, and then this one minus 1. So dapat ni. Again, what we did is using the rules of differentiating using polynomial. Ni bring to the front, and then this one minus 1. Again, you can see here, right? Sama juga. Technique, bring the n plus r to the front, yes. And then this one minus 1. And then my starting point start at n equals to 0. Why? Anyone? What I'm talking today is the review, and you have to understand this. If not, it will be a big problem. Are you okay? Why is it start from 0? Why? Okay, when we substitute again for the second time we differentiate. Okay, again yang ni bring to the front dapat hak ni. Now this one -1, that's why dapat R -2. This one you bring to the front dapat this one, right? And then R jadi R -1 and onwards. When we change the infinite polynomial to series, okay, bring this to the front, that's why I have n plus r and n plus r minus 1 en. This one minus 1 dapat yang ni. And my starting point masih lagi n equal to 0. Why? Nampak tak kat sini? N naught tu ada tak?
Ada.
Dia tak hilang tu.
Betul.
That's why you always start at n equals to 0. When you differentiate again for the third time, masih lagi ada n. Sebab dia tak akan hilang. See the difference between power n, when you differentiate power n, each time you differentiate satu term kita buang. The first one buang A0, the second one you buang A1, the third one you buang A2, the fourth one you buang A3. Tapi whenever you have a series with power n plus r, you never throw out any terms. And it always start at n equals to 0. So mind your notation. Please remember, okay, the difference between power with series of integer n, power of series with integer n, and power with series with integer n plus r. So nampak beza dia? Sama juga kat sini, when you have the third derivative, always start from 0. Sebab dia adalah the third one. See the difference between those two power series when you differentiate and how and why. So please take note of this. Right? Alright. Okay, last one before we end. Shifting the index of a power series. Okay. When we have 3/4 plus 1/2, final answer should be, berapa jawapan dia? Apa perlu kita buat supaya kita dapat jawapan?
Samakan berjemput.
Denominator.
Samakan denominator. Maksudnya setengah ni kena, if we want answer as 4, betul? Betul tak? Samakan denominator. Setengah ni we need to change it. Dia jadi apa? Samakan denominator kan? Jadi berapa ni?
5/4.
2/4. Macam mana dapat 2/4? What will be the process atau teknik yang you use? Apa dia? Tak dengar. Halusnya suara. Siapa sebut tu? Can you speak again? Kita ni nak habis dah ni. That's why I hate online. Bila saya tanya senyap. Harith, tak dengar lah Harith. Apa yang XX ni? You all dengar suara saya? Suara saya semakin lama semakin kuat dah rasanya. Oh, okay.
1/2 times 2.
Times 2 macam mana nak times 2 tu?
1 times 2, 2 times 2.
1 dan 2 times 2. Jawapannya 1. Gini.
No. Atas darab 2, bawah darab 2.
Atas darab 2, bawah darab 2. So dia akan jadi 2/4. So times 2, teknik dia adalah, metodnya adalah multiplication of constant at the numerator and also denominator. Boleh tak saya buat setengah? Bawah je lah. Darab bawah ni. Saya nak darabkan yang bawah je. Hilang pula sebenarnya. Dah. So jawapannya 1/4. Sebab kita nak 4. Boleh tak yang ni?
Tak boleh.
Syarat untuk menjadi fraction yang sama, mestilah darab atas bawah. Betul? Ni regulation je. Okay. And then 2/4 ini kita namakan dia apa dengan 1/2? 1/2 sama dengan 2/4. So 2/4 ini kita namakan dia apa? Setengah adalah fraction. 2/4 adalah apa kepada setengah? Dia sama tapi tak serupa, betul? Sebab ini nombor dia kecil 1/2. Yang ini dia tak serupa, nombor 2 dan nombor 4. Sama boleh jadi 3/6, betul tak? Tapi nilai dia sama. Kita pakai apa ni? 2/4 dengan 3/6 ni? 500/1000. Kita pakai apa? Kita pakai apa? Tak ada siapa cakap. Kita panggil apa? Banyak bulan puasa ni. Sama banyak. Kita panggil apa? What do we call 2/4 regarding 1/2? What do we call 3/6? What do we call 500/1000? Is equal to? Yeah, equal to what, young man? Equivalent fraction. So the process in order to do summation of a fraction within another fraction, we have to find equivalent fraction for 1/2 in order to come up with the final answer, which is 5/4. If not, we cannot do the adding of the process. This is what we did last time. Sama juga the process of adding two series. Example here. When we have two series, syaratnya power index must be the same. But this one, power index are not the same. Starting are not the same will be no problem, right? Because last time what we did, when we add two or three series, as long as the power index are the same, regardless of the starting point, we can definitely add as long as we find which common starting point, and then kita boleh terus add. The common starting point is 4. Barulah kita gabungkan tiga-tiga. Okay, this one powernya dah tak sama. Okay, ni saya tunjuk power ini. Kenapa we want to add, kenapa we are using multiplication. Sama juga, right? Sama juga, saya ada kat sini. Okay, sama juga when we have two series, when we have to add the two series, we want to find equivalent series. And the process of to find equivalent series, kita namakan shifting of the index. Kalau untuk fraction, kita using multiplication of constant, okay, both numerator and denominator, itu adalah teknik to find equivalent fraction untuk setengah. untuk series, we are using shifting of the index to find equivalency. Dia tak ada banyak, konsep dia sama je. Cuma sekarang ni kita belajar dalam bentuk series bukan fraction. So how do you get equivalent series? Okay, shifting of the index. Again, how do you do that? When we have n, kita nak shift supaya ia menjadi n sahaja. N plus 2 nak jadikan n, we kena buang 2, betul? So by n, I change it to shift it to n minus 2. The process of shifting, the notation is this. N, one single arrow, n minus 2. It means n is downward shifting by 2. Need the way you say it, right? And then again, every single n that you have in the series, there's 1, 2, 3. Every single n you have to shift. So my n, I shifted to n minus 2. See, I put it in the right hand. This n now n minus 2 and this n is n minus 2. Similarly, when you do fraction, atas bawah, dia tak boleh buat bawah sahaja, dia tak boleh atas sahaja, mesti atas bawah. Numerator and denominator. Similarly, when you do shifting of the index, jangan nak buang power index sahaja, but you need to shift every single n that you have in the series. Kalau 3 lah. Kalau ada 5 n dalam series, that every single 5 n you have to shift. So when you do the shifting, then simplify it, n sama dengan 3, bn minus 2 are now here. When you simplify dapat n, this one adalah equivalent series untuk yang ni. Okay, this is your equivalent series for the one that you have earlier. Alright. Is it the same? Nampak tak? This is your equivalent series. Dia tak serupa. Yang ini power n plus 2, and that's the latest one after you do shifting. Now the power becomes n. Is it the same? Yes. How? You expand the series. When n equals to 1, dapat b1 power 3. When n equals to 2, you got b2 power 4. This one, when n equals 3, nampak? The starting dari lain. When n equals to 3, 3 tolak 2 is b1. Okay, power 3. When n equals to 4, the second term, okay, got to the power 4. Nampak Walaupun dia tak serupa, nilai tetap sama. Okay, and then hence, when you solve the two series, when you want to add, so this power are not the same, so you need to find equivalent series. So what you need to do is you need to do this only. Just tell me what is the process of your shifting. You tak perlu tell me everything like this one, no need. As long as you understand, you just mention what is the shifting process that we need to do, and it's shifted n minus 2, right? And then give directly the answer. N now become n plus equals to 3, n now bn now become bn minus 2, and this one shifted to n. And then you can give the final answer. Are you okay with that? And then this is try it yourself. Answer pun saya dah bagi. Okay, so we have 5 more minutes. Can you try it yourself? So the first one here, n is shifted. What is the shifting process? You add or you subtract? Shifting outward or shifting downward? Okay, when we have n plus 1, we call it shifting upward by 1. When n minus 2, then we call it downward shifting by 2. This is what how downward shifting by 2, and this is upward shifting by 1. Okay. Yang ni, you nak downward shifting ke upward shifting yang guys, ladies?
Downward.
Downward, upward shifting by 1. Kan? Kita nak hilangkan tolak 1. Okay, this one, no need. This one, downward shifting by 3. Nampak kan? Okay, so again, every single n tukar. So n sini plus 1, now it becomes 0. A n plus 1, x minus x naught, now become m sahaja. Yang ni tak berubah. Okay, sama je. And this one, n start from, tukar ni, nampak 3. So n start from, tolak yang 3 ke depan. So Cn tolak 3, x minus x naught power n. Jadi dapat nanti yang ni terus. Sebab kita dah tak ada masa dah ya. So aku nak jawab habis. So next step yang ke ni. Okay. What we did here is shifting of the process ini adalah, okay, shifting ni adalah step 4 dalam process of solving ODE later on. Okay. Dan step review 5 and review 6 we are going to do that di mana subhanallah. We are going to do that later next week lah insyaAllah. Ada apa-apa persoalan? It's 9:48, 2 more minutes. Ada apa-apa? I'm going to stop sharing. Ada apa-apa persoalan? So please continue. If you have any problem, let me know. You can use the what do you call it? You can use the WhatsApp if you have any problem that you want to ask me, and you can show me your work. Okay, if I have a masa, I can look into it. Ada apa-apa persoalan? That's it for me. Okay, I have reviewed what is a power series. We know how to add the power series. We know how to differentiate power series. And the fourth one, you know how to find the equivalent series. Ni semua basic about series. How to add, subtract, how to differentiate, how to find equivalent series daripada series yang biasa, apa dia punya equivalent series and so on. Right? So next week, Monday, we are going to continue with Taylor series and also principle of superposition. Kemudian hari Selasa minggu hadapan, Rabu minggu hadapan, barulah saya masuk solving ODE. Ada apa-apa persoalan? Ada tak ada. Alhamdulillah for today. Kalau ada apa-apa persoalan, you can always write to me, and I'll see you all Selasa next week insyaAllah, together with 4C1 4C1 yeah, okay. Kalau ada somebody, sorry lah saya tak dapat tengok. 8 error 2 orange. Sorry lah Mio saya tak tengok pun dalam chat. Yes, you give me a guidance. Alhamdulillah for today. I'll see you all Selasa. Apa-apa WhatsApp dengan saya. I end our session with Assalamualaikum warahmatullahi wabarakatuh and selamat berpuasa. Alright. Okay, bye-bye dear.
Terima kasih, Kak Nel.
Betul.
Thank
Terima
you.
kasih, Doktor.
Puan, that's not doctor.